Welcome to the nervous system. I have begun this on part 2 to start with the brain and the spinal cord. And the question is, why did the central and peripheral nervous systems develop? What evolutionary role do they have? Nervous systems developed initially in single-cell organisms as receptors, and they kept organisms alive by predicting the outcome of their movement. Single-cell organisms evolved to move. They had some cilia, they were able to swim around, and the single-cell organisms that had little photoreceptors, or receptors in the front that would bounce off an object, turn 20 degrees right or left, and keep moving, lived longer. And as we became multicellular organisms, we began to evolve more and more complex signaling systems to predict the outcome of our movement. As we began to evolve very complex nervous systems, we began to predict the outcome of our movement using strategy. And strategy began to become consciousness. As we continued to evolve, we had emotions. Emotions are predictions of meaning versus chair versus electric chair. We have a meaning of electric chair versus chair. And so all of the central nervous system's job is to predict, to determine what is going to happen in the future. Our imagination is a form of prediction. Reality versus future. Reality for us is simply a way of looking at our own perceptions, and itself is not true reality, but just our perception of that reality. The nervous system is divided between central nervous system and peripheral nervous system. The central nervous system includes the brain and the spinal cord. So here, we need to raise this screen up a little bit. I think we're missing part of our brain, but the brain is here and the spinal cord is here. So the brain and the spinal cord comprise the central nervous system. All of the nerves which come off the spinal cord or the brain are called peripheral nervous system. So these cranial nerves are nerves that come off the bottom of the brain. Spinal nerves come off the spinal cord. All of the sensory organs, eyes, nose, tongue, ear, skin, they are all going up. They are all part of the peripheral nervous system. So when we look at the nervous system, we look at the brain, and I'm unable to capture the brain easily. There we go. I capture the brain in the image here. The brain actually sits inside the skull, and it is floating in fluid that we call cerebrospinal fluid. And the cerebrospinal fluid is secreted by little ventricles or cavities within the brain. And the fluid circulates around the brain and all the way down around the spinal cord. The spinal cord ends right about here. And it bathes the brain in this fluid. Understand that the brain taken out of the skull and put on a table will simply flatten out like a pancake and dribble down onto the floor. The brain cannot support its own weight and must therefore be floating in fluid to make it buoyant and lighter. So the brain is surrounded by 3 membranes. The outer is the dura mater, the middle is the arachnoid mater, and the inside is the pia mater. So let me change here. So this is the skull, and this here is the brain. We have the dura mater. Dura means tough. The dura mater has been known at times to deflect bullets. I have broken scalpel blades on the dura mater. Then there's a spidery called arachnoid motor. In other words, spider mother. This is tough mother. Yes, that's what the word means. Arachnoid motor, spider mother, because it's meshy like a spider web. And then the pia motor. Pia means tender. So this is the tender motor. It is actually adhered to the surface of the brain itself. Between the arachnoid motor and the pia motor, we have a cavity where the cerebral spinal fluid exists. So the cerebral spinal fluid is between the arachnoid motor and the pia motor. Also in the central nervous system, when we have clusters of nerves, we call these nuclei. When we have clusters of nerves in the out of the central nervous system, in the peripheral, we call them ganglia. But the brain will either have nerve clusters or nerves arranged like a map. So here is an image of a brain. On one side, on the left, is a normal hemisphere of the cerebrum, and on the right is an Alzheimer's brain. So first, let's talk about a few things about the hemispheres of the brain. So you have a hemisphere on the left, and you have a hemisphere on the right. Then you have structures in the middle that start the brain stem, that come all the way down. Around the surface of the brain is dark gray. In the middle is white. The dark gray comprises the cortex of the brain, and these are nerve cell bodies. Nerve cell bodies in 6 specific layers, which I will show you an image of. These would be the 6 layers of the cortex surrounding the cerebral hemispheres. Humans have 6 layers, other animals have fewer layers. These layers of neurons are laid out like a map. This is why we can read maps, because we have neurons laid out like a map themselves. The neurons start in their layers and they come down. Now, this is gray and this is white. The white matter means the neurons are wrapped in a lining called myelin. And so in the central nervous system, you will see gray matter and white matter. In a normal brain, you're going to see a lot of gyri. You're going to see profound tissue. In an Alzheimer's brain, we have tanglements that begin to kill the neurons, very specific to the short-term memory areas, and the brain begins to shrivel. So the cortex shrivels up, damages the areas involved in thinking, planning, and remembering. The ventricles we talked about with the cerebral spinal fluid grow too big, and this area for memory starts to shrink severely.